Good morning, students. Welcome to 10th Science, Unit 11, Carbon and its Compounds, Part 1. What are the learning objectives? To know the importance of organic compounds. To classify the organic compounds and name them based on IUPAC rules. To identify the functional groups of organic compounds. To explain the preparation, properties and uses of ethanol and ethanoic acids, and to know the composition of and preparation of soap and detergent, to understand the cleansing action of soap and detergent, and to differentiate soap and detergents. Now, introduction of carbon and its compounds. Carbon is a non-metal. Without carbon, no living thing could survive. Human beings are made up of carbon compounds. The symbol of carbon is C. The atomic number of carbon is 6. The atomic mass of carbon is 12. And its valency is 4. Carbon, they combine with other carbon atoms and they form a living organisms, and they form a building block of organisms, and they decide life on earth. So carbon chemistry is called as living chemistry. Carbon compounds circulates through air, plants, animals and soil by complex reactions, and they are called as carbon cycle. So, more than 5 million compounds of carbon. There are innumerable number of carbon compounds in our day-to-day life. The food we eat, medicines we take when ill, clothes we wear, domestic and automobile fuels, paints, cosmetics, automobile parts, etc. So they contain carbon compounds. So the carbon compounds are, carbon means C. The carbon compounds are CO, carbon monoxide, CO2, carbon dioxide, CCl4, carbon tetrachloride. So these compounds are called as carbon compounds. One or more atoms of carbon are covalently linked to atoms of other elements like hydrogen, CH4, methane, oxygen, CO2, carbon dioxide, nitrogen, CN, and sulfur, carbon disulfide, nitrogen, that is methylamine also, CH3 and H2, sulfur, that is carbon disulfide, etc. So these compounds are called as organic compounds. General characteristics of organic compounds. Organic compounds have a high molecular weight. For example, glucose C6H12O6. The molecular weight is 180, and also it forms a complex structure. They are mostly insoluble in water, H2O, but soluble in organic solvents such as ether, carbon tetrachloride, CCl4, toluene, etc., C6H5, CH3, toluene, etc. And they are highly inflammable in nature. Organic compounds are less reactive compared to inorganic compounds. Inorganic compounds means, example, ammonium nitrate. Mostly, organic compounds form covalent bonds in nature, and they have lower melting and boiling point when compared to inorganic compounds. They exhibit the phenomenon of isomerism. What does isomerism means? The compounds containing the same formula, but the structural formula is different. For example, C6H2, C2H6O, C2H5OH, this is ethyl alcohol. CH3O CH3. This is dimethyl ether. So same molecular formula but different structural formula. So this is called as isomerism. So isomerism in which a single molecular formula represent several organic compounds. They differ in their physical and chemical properties. They are volatile in nature. Volatile means easily evaporated substances in nature. Organic compounds can be prepared in the laboratory. Classification of organic compounds based on the pattern of carbon chain. Organic compounds are classified into acyclic or open chain compounds, cyclic or closed chain compounds. Acyclic compounds can be classified into saturated and unsaturated compounds. Saturated compounds contains a single bond. For example, ethane, C2H6. Unsaturated compounds contains a double bond or triple bond. Double bond name is ethene, CH2 double bond CH2. Ethine, CH triple bond CH. And the cyclic compounds can be classified into carbocyclic compounds and heterocyclic compounds. This carbocyclic compounds, they contain only a carbon ring, and this carbocyclic compounds can be classified into alicyclic compounds and aromatic compounds. The example of alicyclic compounds is cyclobutane. The example of aromatic compound is benzene. And in heterocyclic compounds, they contain a carbon and other elements such as sulfur, oxygen, nitrogen, for example, pyridine, furan, etc. Organic compounds are classified into two types as follows. Acyclic or open chain compounds. So these are the compounds in which carbon atoms, they linked a linear chain, straight chain. To form a chain, that chain is a straight chain. If all the carbon atoms in the chain are connected by a single bond, that compound is called as saturated. For example, propane. CH3, single bond CH2, single bond CH3. So the name is propane. It is a saturated compound. If one or more double bonds or triple bonds exist between the carbon atoms, then the compound is said to be unsaturated. For example, propane, CH3, single bond CH, double bond CH2. This is an unsaturated compound. Cyclic compounds. Organic compounds in which the chain of carbon atom is closed or cyclic. They are called as cyclic compounds. If the chain contains only carbon atoms, such compounds are called as carbocyclic compounds. If the chain contains carbon and other atoms like oxygen, nitrogen, sulfur, etc., these compounds are called as heterocyclic compounds. Example, furan. See the picture, C4H4O. The molecular formula is C4H4O. The name is furan. It's a heterocyclic compound. It's a heterocyclic compound. Then carbocyclic compounds are further classified into alicyclic compounds and aromatic compounds. Alicyclic compounds contain one or more carbocyclic ring. Example, cyclobutane. Closed. That is a cyclobutane. 4 carbon C4H8. It is an alicyclic compound. The structure is this. And this, whereas the aromatic compounds contains one or more benzene ring. Benzene. Okay, this is the structure of benzene. The name is benzene. The molecular formula of benzene is C6H6. C6H6. This is an aromatic compound. Then classes of organic compounds based on the kind of atoms. Hydrocarbons. The organic compounds that are composed of only carbon and hydrogen are called as hydrocarbons. The hydrocarbons are classified into three classes, three divisions. Alkane, alkene, alkyne. Alkane contains a single bond. Alkene contains a double bond. Alkyne contains a triple bond. The general formula of alkane is CnH2n plus 2. The general formula of alkene is CnH2n. The general formula of alkyne is CnH2n minus 2. In the place of n, we put 1. C1, 2 into 1, 2 plus 2, 4. So C1H4. That name is methane, CH4. In the place of n, we put 2. C2, 2 into 2, 4. 4 plus 2, 6. C2H6, that is ethane. So, only one carbon means the name is methane. The carbon, 2 carbon means the name is ethane, C2H6. In the place of n, we put 3. C3H8. 3 carbon means the name is propane, C3H8. In the place of n, we put 4. C4H10, butane. In the place of n, we put 5. The number of carbon atoms 5 means in the place of n, we put 5. C5H12, the name is pentane. Now, alkane. Alkene contains a double bond. So, here, in the place of n, we put 2. C2, in the place 2 into 2, 4. So, C2H4. So, this is the simplest alkene. Ethene, the name is ethene. The number of carbon atom is 2. The name is ethene or ethylene. And the molecular formula is C2H4. And in the place of n, we put 3. Number of carbon atoms 3 means in the place of n, we put 3. C3H6. The name is propane. The number of carbon atoms 4 means C4H8. Butane. In the place of n, we put the carbon number atoms 5. So, C5H10. The name is pentane. Now, alkyne. Alkyne contains a triple bond. In the place of n, we put 2. The number of carbon atoms 2. C2H2. So, the name is ethyne. The number of carbon atoms 3. So, in the place of n, we put 3 means C3H4, propyne. Number of carbon atoms 4. In the place of n, we put 4. C4H6. 2 into 4, 8. 8 minus 2, 6. So, C4H6, butane. Number of carbon atoms 5. In the place of n, we put 5. C5. 2 into 5, 10. 10 minus 2, 8. So, C5H8. The name is pentane. So, the simplest alkane is methane. The simplest alkene is ethene or ethylene. The simplest alkyne is ethyne or acetylene. Then what are the characteristics of hydrocarbons? Lower hydrocarbons are gases at room temperature. Example, methane, CH4, ethane, C2H6. They are gases. They are colorless and odorless. The boiling point of hydrocarbons increases with an increase in number of carbon atoms. For example, methane, ethane, propane, butane, the carbon number is increasing. So, the boiling point of hydrocarbon is also increases. They undergo combustion reaction with oxygen. For example, methane, CH4, they combine with oxygen to form carbon dioxide and water. Alkanes are least reactive because it contains a single bond when compared to the Other hydrocarbons such as alkenes, alkynes, double bond and triple bond. Alkynes are most reactive due to the presence of triple bond. Alkanes are saturated, whereas alkenes double bond and alkynes triple bond. Double bond and triple bonds are unsaturated, and they are insoluble in water. These are the characteristics of hydrocarbons. The last topic, to test the identity of saturated and unsaturated compound. Test to identify the saturated and unsaturated compounds. Come to the picture. Take a given sample solution in a test tube. The first test tube contains alkane. It contains a single bond. Alkene means it contains a double bond. So take a given solution in a test tube and a few drops of bromine water. The color of bromine is purple in color. This is bromine water. You pour a bromine water. Okay, you observe the changes of color, and if the given compound is unsaturated means it will decolorize water will react with bromine water and it decolorizes bromine water. And here, because it is an unsaturated compound. Now here it does not react with alkane, it does not react with bromine water, and it does not decolorize bromine water because it contains a single bond. So saturated, given compound is unsaturated means it will decolorize bromine water. If it is saturated compounds means do not decolorize bromine water. So this is the addition of bromine water to alkenes and alkenes. So this is the test to identify the saturated and unsaturated compounds. Okay students, thank you.